If you see a crow landing beside a bird bath in your yard, don't move. You may miss the small clues that reveal how it thinks. You are watching a prehistoric genius conduct a physics experiment in your backyard. Most people miss the incredible cognitive map being used here. We are breaking down the secret logic behind this behavior. At first, it looks almost ridiculous. A black bird lands beside a water bowl. It drops a dry twig. The twig bobs on the surface. Nothing changes. Then the crow finds a compact, heavy pebble, carries it back, and drops it in. A small ring moves across the water. The crow pauses, its eyes fixed on the waterline, then goes back for another pebble. If you have ever seen something like this, you might assume the bird is playing, bathing, hiding food, or simply making a mess in your pet's drinking water. Those are reasonable first guesses. But there is another possibility, one that turns an ordinary bowl into a miniature laboratory. Because a container of water with food just out of reach creates a problem. And a stone is not simply a stone. It is a way to change the problem. This is the strange, real-world echo of one of the oldest animal stories ever told, Aesop's fable of the crow and the pitcher. But before we call every backyard crow a physicist, we need to be precise. Scientists have shown that some corvids, members of the crow family, can solve carefully designed water displacement tasks. That does not mean every crow you see is deliberately recreating Aesop's fable. It means that when a crow repeatedly chooses sinking objects, watches the waterline, and returns to the same bowl with a clear goal, you may be seeing an extraordinary kind of problem-solving unfold in plain sight. And the most important question is not, is it smart? The real question is, what exactly does the crow understand? To explore that question, let us watch a small experiment. Two containers of the same height are placed side by side. One contains sand with a piece of food inside. The other contains water with the food floating on the surface. At first, the crow watches. Then it picks up a pebble and drops it into the container of water. It lowers its pointed beak and tries to grab the food, but it still cannot reach it. The crow pauses and watches again. Then it brings another pebble, drops it into the water, and tries once more. It repeats this pattern: stone, observation, another attempt, until the water rises high enough for the food to come within reach of its beak. So why did the crow choose the water container? A leaf will float, a dry twig may float too, but a dense pebble sinks. When the pebble goes down, it takes up space inside the bowl. Water has to move somewhere, so it rises around the stone. That is displacement. You do not need equations to see it. Put a stone into a glass filled close to the top, and the waterline climbs. The amount of rising depends on how much space the submerged object occupies, the shape of the container, and whether the object actually sinks. For the crow, this is not a classroom lesson about Archimedes. It is a visible result. Stone down, food up. That simple rule can become powerful. In scientific versions of this challenge, birds have been given water-filled tubes with food floating below beak level. Some corvids learn to drop objects in until the reward rose high enough to reach, often favoring sinking objects over floating ones. That is why the choice between a pebble and a twig matters. The crow may not be thinking in words like density, volume, or hydrostatic displacement. We should not force human language into an animal's mind, but it may have learned a reliable relationship between a type of object, a water-filled container, and a reachable reward. And now the scene gets more interesting. A crow that simply throws everything into the bowl is exploring. A crow that carries a stone, watches the waterline, pauses, then chooses another stone, is doing something more organized. It is gathering information from the result of each action. Look closely at that pause. The crow does not need to drop 50 objects at once. It may place one, check the level, then decide whether the next trip is worth the effort. This is a stop-and-check strategy. Action, observation, adjustment. That loop is the foundation of problem-solving, and it leads to a question that changes the entire story. Is the crow only repeating what worked before? Or is it building a flexible mental model of what water, objects, and containers can do together? Because the answer is not as simple as, crows are brilliant. In fact, the limits of their performance may be just as revealing as their successes. Let's make the challenge harder. Place two objects beside the bowl, a cork and a pebble. The cork is larger. The pebble is smaller. Which one should the crow choose? A human who understands the setup knows the answer. The pebble. The cork floats. The pebble sinks, displaces water, and raises the level where it matters. Now place two sinking stones beside the bowl. One small, one large. The larger stone may raise water more, especially in a narrow container. But a shallow bowl can spill. A wide one can make every pebble ineffective, and a low water level can make the reward too costly to reach. A backyard scene has become an engineering problem. Materials, container shape, effort, risk, and reward. Researchers have tested related questions by changing the tubes, water levels, objects, and hidden connections between containers. The results are impressive, but they are not a blank check to claim that crows understand every invisible physical mechanism. In some experiments, New Caledonian crows showed a sophisticated but incomplete grasp of water displacement. They succeeded in several practical tasks, yet struggled when the setup required them to infer a hidden connection or transfer what they had learned to a more unusual version of the problem. Intelligence is not a single magic power. A crow can be remarkably good at detecting useful patterns while still being confused by a change that humans find obvious. Great apes, corvids, and children can all solve certain physical problems, but similar success does not prove identical thoughts. The word reasoning can hide two very different processes. The first is trial and error learning. An animal tries something, gets a reward, and repeats it. The second is more flexible causal reasoning. It can adapt to a new container, object, water level, or route to the same goal. Real behavior may include both. A crow may begin with exploration, then improve through feedback. It may not carry a formal equation in its head, but it can form useful expectations. This object sinks. That object floats. This tube gets the food closer. That wide bowl wastes effort. Here is where the mystery becomes personal. What happens when the crow's solution stops working? Suppose the water bowl is too wide. The crow drops one pebble, then another, then another. The water barely rises. At some point, the bird faces a decision. Keep investing effort. Search for a heavier object. Try tipping the bowl. Look for a different food source, or abandon the task. That decision is not failure. It is the moment intelligence becomes visible. A flexible problem solver does not just repeat an action forever. It notices diminishing returns. This is why the setting matters. Crows encounter puddles, roof gutters, bird baths, pet bowls, and cups left outdoors. Human spaces create unusual physical problems and unusual opportunities. Cities and suburbs offer predictable food sources and a map of objects to investigate. The more honest question is, how does this particular bird adapt with the materials it actually has? Maybe it ignores a floating leaf, chooses a pebble over a twig, or returns tomorrow because it remembers where water and food have been available. Watch the sequence, not just one dramatic drop. Does it inspect objects before choosing? Check the water after each drop? Switch strategies when the bowl changes. Such patterns are more revealing than a single action. And there is another layer, social learning. Young crows watch parents, siblings, rivals, and neighbors. They learn which yards are safe, where water collects after rain, and which objects are worth investigating. Some corvid tool traditions are shaped by learning and can pass between generations. An urban crow is not merely surviving in the human world. In many ways, it is studying it. Every open container becomes a question. Every predictable food source becomes a memory. So, is the crow sending you a life-saving message? Not in the supernatural sense. It is not a warning from the future. It is not necessarily trying to teach you physics. And one crow dropping something into a water bowl is not enough evidence to declare a scientific breakthrough in your backyard. But there may still be a message here. The crow can remind you that intelligence does not always look human. It does not always speak. It may arrive with black feathers, a cautious step, and a pebble held in a beak. It may be hidden in a pause beside a waterline, and it may tell you something practical. Water is valuable. Accessible food changes behavior, and your garden is part of a living network of animals, making decisions around you every day. So do not rush outside to chase the crow away. First, protect your pet's water. Replace the bowl with fresh, clean water if a wild bird has been using it, and keep food dishes indoors when possible. Do not feed or train wildlife to depend on you, and do not try to recreate risky experiments with animals. Then step back, watch quietly, because maybe the most life-saving part of this story is not the crow's message to us. Maybe it is the reminder that a living creature does not have to resemble us before its mind deserves our attention. The next time you see a crow choose a stone over a twig, do not just see a bird making a mess. See a question being asked. See a problem being tested. See an ancient mind meeting a modern world and finding a way through it.